In topic 2.2 today, we're looking at trig ratios of any angle from 0 to 360 degrees. First of all, what we're going to do is establish a point on the plane xy. Notice that this point xy is x units away and y units away above the y-axis, the x-axis, and the y-axis. That point can be found as the distance from the origin of r, and r is going to equal the square root of x squared plus y squared. That angle that was made with the triangle is going to produce some important relationships. We're going to use the reference triangle to determine the three primary trig ratios. So what we're going to do is sine of this angle is going to be opposite, which is y, over the hypotenuse, which is r. The cosine of this ratio is the adjacent side x over the hypotenuse r. And then the tangent of this angle is going to be the opposite over adjacent, or y over x. Now if we look in the four separate quadrants, we're going to see how this is going to work. Notice that the distance from the point from the origin, xy, in the first quadrant. In the second quadrant, it's going to be negative xy. The sine is y over r, cos is x over r, and tangent's y over x. This means that the sine is going to be greater than 0, cosine is greater than 0, and tangent is greater than 0 in the first quadrant. In the second quadrant, the sine of the angle is y over r, cosine is negative x over r, and the tangent is y over negative x. So that tells me that the sine is going to be positive in this quadrant, cosine will be negative, and tangent will be negative. Now if we looked at the reference angle in the third quadrant, it's negative y and negative x. So the sine is going to be negative y over r, or negative. Cosine is negative x over r, and that's going to be negative. And the tangent of the angle in this quadrant is going to be negative y over negative x, which is positive y over positive x, and that's going to be greater than 0. And in our last quadrant, we have x, negative y, and we're going to look at the sine is going to be negative y over x, cosine is going to be x over r, positive, and the tangent is negative y over x, negative. So now we have something that we're going to call the cast rule. And what that's going to do is it's going to determine the sines of sine, cosine, and tangent in each of the quadrants. In the first quadrant, all three are going to be positive. So A stands for all three. In the second quadrant, only the sine ratio is positive. In the third quadrant, the tangent ratio is the only one that's positive. And in the fourth quadrant, cosine is the only one that's positive. This is called the cast rule. Let's look at an example. Write trig ratios for angles in any quadrant. Well, the point negative 8, 15 lies on the terminal arm of an angle in standard position. Determine the exact trig ratios for sine, cosine, and tangent. Well, if we draw this, when P is at negative 8, 15, that's going to be in the second quadrant. Now we can say that the sine is going to be, well, first of all, we have to figure out what r is. So we're going to say 15 squared plus negative 8 squared is going to give me c squared, and 64 plus 225 is c squared, which is 289, and the square root is 17. So now we have r. We can figure out that the sine is going to be 15 over 17, opposite over hypotenuse. The cosine of our angle is going to be exactly negative 8 over 17, and the tangent of our angle is going to be 15 over negative 8, which we will write out front negative 15 over 8. Your turn. On your own, determine the exact trig ratios for sine, cosine, and tangent. Here's the answer. When you draw this out, you're going to get sine as being negative 12 over 13, cosine is negative 5 over 13, press the wrong button, and tangent is going to be 12 over 5. In example 2, we want to determine the exact value of the cosine of 135 degrees. Well, if we draw 135 degrees as an angle in standard position, that will create a reference angle of 45 degrees. The 45-degree reference angle is what we're going to use to determine our exact value for the cosine of 145. So remember now, for a 45-degree angle, the point that it's going to go to is going to be 1, negative 1, and root 2. This is from the triangle that we developed in topic 2.1. So now we can say the cosine of a 45-degree angle is adjacent over hypotenuse. So the cosine of 135 degrees is going to be negative 1 over root 2. Your turn. Determine the exact value of the sine of 240 degrees. Well, that's going to be in the first, second, third quadrant. Oh, I didn't do this one. Suppose our angle in standard position with a terminal arm in quadrant 3 and cosine is negative 3 over 4. Find the exact values of sine and tangent. Well, it's in quadrant 3. We're going to draw the reference angle, and since it's negative 3 over 4, adjacent is going to be negative 3, and the hypotenuse is going to be 4. And if you solved a squared plus b squared plus c squared, x is going to be worked out to be root 7. We're going to leave this as positive or negative root 7, and here, since it's going down from 0, here we're going to have x is equal to negative root 7. So I'm going to erase the x and put negative root 7 there. Now I can give the exact values of the sine of our angle and the tangent of our angle. The sine of our angle are going to be opposite, which is negative root 7, over hypotenuse, which is 4, and the tangent of our angle is going to be negative root 7 over negative 3, which of course the negatives will cancel out to become root 7 over 3. And your turn. And you can finish those two off on your own. On 4, determine the trig ratios of quadrantal angles. These are angles of 0, 90, 180, 270, and 360 degrees. So we want to find the values of sine, cosine, and tangent when the terminal arm coincides with a positive y-axis. Well, let's draw that picture. There we have the point xy. Except this time, x is going to have a value of 0, and y is going to be the same as r. Therefore, the sine of 90 degrees, remember, is y over r, which is y over y, which is 1. The cosine of 90 degrees is going to be x over r, which is 0 over r, which is 0. And the tangent of 90 degrees is undefined because it's going to be y over 0. In your turn, we want you to use the diagram below to determine the values of sine, cosine, and tangent for quadrantal angles of 0, 180, 270 degrees, and then to complete the table that I'm going to put up here in a moment. Here we have the 90 degrees has already been done for us. Well, we just did it. And if you work all of these things out using the method that we just learned, you're going to find that here we have some of them worked out for you, You can double check these, and here we have your values. In example 5, we're going to solve for an angle given its exact sine, cosine, or tangent value. If we solve for our angle, if the sine of our angle is 0.5, and that's between 0 and 360 degrees, we want every angle that's going to have a sine of 0.5. So here's what we're going to do. Remember the cast rule? Well, since the sine ratio is positive, it must be in quadrant 1 and quadrant 2. It's positive because it's positive 0.5, not negative 0.5, it's positive 0.5. Therefore, if we drew our reference angle of 30 degrees in quadrant 1 and in quadrant 2, we can do that because the sine of our angle is 1/2 or 0.5, and the sine of 30 degrees is going to give me a reference angle of 30 degrees. That tells me that the angle in standard position is going to be either 30 degrees for the first one or 150 degrees for the second one. So my angles could be 30 or 150 degrees. For B, the cosine of our angle is negative root 3 over 2. Now we want to know the angles between 0 and 180 degrees, 360. Well, cosine is going to be negative in quadrant 2, and it's going to be negative in quadrant 3, but our domain is limited to 0 to 180 degrees, so we only have to worry about quadrant 2. Excuse me. Therefore, when we take a look at our triangle, we're going to develop when is cosine equal to negative root 3 or even root 3 over 2. Well, cosine is root 3 over 2 for the 30-degree angle, and it's going to be negative in quadrant 2. So we're going to draw it there. There is our adjacent, which is root 3. There is our 2, which is the hypotenuse. And that means for a 30-degree angle, again, my only solution is going to be a reference. The reference angle of 30 degrees means you're going to have an angle in standard position of 150 degrees. And again, you can check this with your calculator to see. And if you pressed in the cosine of 30 degrees, you're going to get negative. The cosine of 150 degrees, you're going to get negative root 3 over 2 in decimal form. Your turn is to solve the sine is negative 1 over root 2 between 0 and 360 degrees. Again, you can work on that on your own. Our last example. Given that cosine is this value, between 0 and 360, determine the angle measure. All you can do in this case is press the cosine inverse of the positive 0.6753, and that'll give us a reference angle of 47.5 degrees. When you draw it in quadrants 2 and in quadrants 3, you can see that you're going to have an angle in standard position of 180 minus 47.5, which is 132.5, and the second one is 180 plus 47.5, or 227.5 degrees. So that's how we work with this. Your assignment is to do page 96, numbers 1 to 13.